For this in class. Pyramids is a third, length times width times height, right? Did this in class. Okay, this one we didn't have time to do 2, but you know how to find the volume of a cone. 3 we did in class. This will be a test question, okay? 4 we did in class. 5 we did in class. 6 we did B in class, so you need to do A. So this is, and I went over how to do it. So the total volume is half of a hemisphere, half of a ball. Find the whole thing divided by 2 minus the cylinder. Okay, so if you forgot the formula for half of a sphere, we call that hemisphere. You can do the 4 over 3 pi r cubed after you get that answer divided by 2. Okay, and then minus the cylinder, which is pi r squared times height. So total volume is 4 over 3 times 3.14. Radius is 6 cubed. Get that answer divided by 2. So use a calculator, do the numerator first, and then divide that answer by 2. The only way I get the accurate answer is to do one thing at a time. So if I, on the calculator, I put too much in, it won't work. So a cylinder, the 3.14 for pi, radius is 6, squared times height is 13, and then get that and subtract the answer. Okay, we did this in class, and here we did this and started in class, but students were confused. This is the biggest cone. The biggest cone is this one here. Okay, so I'm going to draw the biggest cone out so some of you can see. So the big cone is that one, right? And it is 4.5, the radius, and the height is this whole thing right here. That is 42, because 16 plus 26 is 42 centimeters. And then the small cone, this is where a lot of kids are confused. That's a big cone, right? Here's the small cone. If you don't see it, there's the small cone. Okay. So it's the big cone taken out. You take out the small cone. Okay. So it's big minus small. Big cone minus the small cone. That total volume. We take out the small cone. So go ahead, find the volume of each. I will look for your work. You know how to find a volume of a cone. So volume of a big cone is pi r squared times height divided by 3, which is for both. That is also the formula for the small, but the big one of volume is, let's use 3.14 for pi, times the radius, which is 4.5 squared, times the height, which is, we know it's 42, right? And then divide that answer by 3, minus the small cone, which is same formula, 3.14 times the radius, which is the radius small cone is right here, right? The radius of small cone is this one, 3.5 squared, times the height, which is the 26. Divide that by 3, get each answer. Do one step at a time because the calculator will get you wrong like it did me. So make sure you do all this first, all this. Put the answer down, and then divide it by 3. Okay, put it down, and then get the answer, write it down, minus, write it down, get your answer there. Okay, this one is different. This one is number 9. We got 2 things. Big cone, right? You guys see the big cone? Minus the small cone. Because this is the dot, dot, dot is taken away by a small cone, right? And then they put in, after they take that out, they put in a cylinder in its place. After they take out the small cone, they add that cylinder in. So it's plus the cylinder. Okay, big cone. The big cone, this is 10 plus the 20, so that's the height of the big cone. So we know volume of a cone is up here. That's the formula. So big cone is total volume equals to 3.14 pi r squared radius. Radius is 10 because it's 20 in diameter. 10 squared times the height, which is the 20 plus the 10, which is 30. Okay, and then minus the small cone. We divide that by 3. Don't forget divide by 3. Okay, the small cone is this one here. Let me get rid of all this so you guys can see the small cone. This is the small cone right here. The diameter is 4, so the radius is 2. The radius is 2, so 3.14 times 2 squared times the height of it, which is 10. Divide that by 3. Subtract that. After you subtract that, you add. Make sure you do each one of these and subtract it first. Adding and subtracting, you do left to right. Then add the cylinder. The cylinder is pi r squared times h, right? We'll just put it here. Pi is 3.14 times radius, which is 2, times height, which is 10. Do not divide it by. And then you get, after you do each one, add them all up, subtract and add to that, you'll get your total volume. Make sure you put centimeters cubed, okay? All right. Number 10. A tennis ball company is designing a new ball that can hold 3 tennis balls. They want to waste as little space as possible. How much space does each can waste? Which can design should they choose? Also, you have to find the cylinder first. Let's do this one first. That one is like this problem here, right? So you know that okay, the ball is a bit smaller than the cylinder. Okay, it's the cylinder first. It's the cylinder. SY. All of a sudden I forgot how to spell cylinder. Anyways, minus the 3 balls. All right, and then compare that to the other one, which is the cone minus the same 3 balls. So once you get the answer to this one, you can just put it here. And then you'll know the answer. Okay, so the first is a cylinder. The cylinder is pi. The formula is pi r squared times height. We're finding total volume, so we put V T equals 3.14 times the radius, half of 2.75. I need a calculator for that one, actually. $1.375. Square that times the height. The height of it is 7.75. And then get that answer. There's no dividing by 3 because it's a cylinder. And then minus it to the, I hope I gave you guys enough space. It's harder to write. So minus it to the 3 balls, which is 3 times pi r cubed, right? No, 4 over 3. Forgot the formula. 4 over 3. 4 over 3 pi r cubed. And then pi is 3.14. Times the radius is 1.25 cubed. Get that answer, subtract it, and you see what's left. You want to see which one should they choose to have the waste, how much space does each can waste, which design. So how much space is left here compared to how much space is left here. We want the least amount of space. So then you do the same with the cone, okay? I'll leave you guys to do this. I'm explaining it. Got a calculator, do the steps. Okay, and then here, with multiplication, you got to add the exponent if the bases are the same, right? So -4, that's -1 times 4. There's no other coefficients. The 3, we always start with the numbers first. There's no other coefficient of 3, 2, they're all different, right? If they multiply them, you get -24. And then your x to the -2 with the 2 plus the 2. Y, you get y to the -4 plus this -2. So you get x to the 0 power, y to the -6. So this is 1 times -24 is -24. And this goes on the bottom. That's the answer there, okay? Now this is the same essentially. Oh, I forgot to put another here, but distribute, distribute, distribute. It's 2 to the 5th, m to the 5th, n to the 5th. Distribute, distribute. M to the -3, p to the 3rd. Oh man, can only add these two together right there. M to the 5th plus -3. N is there, p, there's nothing to add to. So your answer 2 to the 3rd, 5th is 2 times 2 is 4. That's 16 times 2 is 32 over. All of them are positive. M to the 2nd, N to the 5th, and P to the 3rd. Okay, and then this one, I'll do this one and you guys do the last one. So, You subtract 9, because these have different base, you just go ahead 9 over 27, which is reduced to 1 over 3. And then a to the negative 4 minus, and that's a negative 2 for a. And then b to the third minus third. Same thing, that's 1. Okay, can't have negative exponents, so you got 1 over 3 a to the second. And do d on your own. I think you can, the 4 have the same base. Notice the base are the same. Subtract them. Okay, 4 to the second minus 3. Do that. Show work, please.